Okay, before we start today's lesson on mole-mass relationship, I want to review the mole very quickly. 4 terms we're going to talk about. As you recall, a mole is the amount of a substance that contains 6.02 times 10 to the 23rd representative particles of that substance. Now, the 2 parts of that statement I want to talk about are, or remind you of, Avogadro's number. Mr. Avogadro was the one that determined that the number of representative particles contained in 1 mole of substance is equal to 6.02 times 10 to the 23rd particles. He's the one that came up with this concept. So we've named that number 6.02 times 10 to the 23rd after him. What is a representative particle? Well, when we're talking about moles, it's the smallest unit into which a substance can be broken down without a change in composition. And usually we're talking about atoms, molecules, which are covalent compounds, or ionic compounds and ions. So in this one, we'd be talking about formula units. That's the ions, formula units. And when we're talking about formula units, let me just expand on that. For instance, if we had the ionic compound sodium chloride, we know that's an ionic compound that doesn't really form a molecule. It forms a formula unit, and that would be the representative particle for ionic compounds. Okay. Next, lastly, we'll talk about molar mass, which we learned yesterday. It is a term used to refer to the mass of 1 mole of any substance. And I think our example yesterday was sodium trioxide. We know that that has 1 sodium. Did I say sodium? I meant sulfur. I'm sorry about that. Sulfur trioxide. 1 sulfur, 3 oxygens. And looking at the periodic table, we know that 1 sulfur weighs 32.1 grams per mole. That's the same number as its AMU, shown on the periodic table, okay? And we know that oxygen weighs 16.0 grams per mole, and we have 3 of those guys. So when we add these together, we get a total molar mass of 80.1 grams per mole. This is a molar mass, and we're going to talk about mole-mass relationship more today. Here we go. The mole-mass relationship. You can use the molar mass of an element or compound to convert between the mass and the moles of the substance, okay? Now, here are my 2 conversion factors right here. And where did they come from? They came from this statement right here. Let me write that to the side. Your molar mass equals 1 mole of that substance, okay? Now, what you can easily do Okay, so based on this relationship right here between moles, molar mass and moles, you can do the following. If your molar mass in grams equals 1 mole of that substance, then you can divide both sides by 1 mole, or you can divide both sides by grams of the molar mass. And you get the following 2 conversion factors. Here we go. You can get molar mass in grams over 1 mole. That equals 1. Or you can get 1 mole over the molar mass in grams. Okay, those are your 2 conversion factors. They both equal 1, and this is how the book shows them. Remember that molar mass is in grams. Okay? That is your mole to mass relationship. How do we use it? We can use it in two ways. The first way we use it is to convert moles, the number of moles, to mass. This is probably sample problem 10.5 in your book on page 318. I'll work it right here, and then you can work a couple of practice problems. We're talking about aluminum oxide, okay? And what we want to know is the mass in grams of 9.45 moles of aluminum oxide. The first thing we have to do is find the molar mass of aluminum oxide. We know that aluminum oxide is 2 aluminums plus 3 oxygens. And we further know that aluminum is 27.0 grams. That's its molar mass. Grams per mole. I'm going to go ahead and put per mole. And I'm going to add that to 3 oxygens, and we know that oxygen has a molar mass of 16 grams per mole. See that? So I've got 3, because I have 3 oxygens, times the molar mass of oxygen right there. And once I do the math, I get, my assistant had one just brought to my attention, and I left a 2 off right there. So, backing up, 2 aluminums, 3 oxygens, right here. That's 2 times the molar mass of aluminum, and 3 times the molar mass of oxygen, which is 16. And when I do all of that, I'm going to get 2 times 27 plus 3 times 16 equals 102 grams of aluminum oxide per 1 mole. That's your molar mass right there. Next, we are given 9.45 moles of aluminum oxide. I'm going to put that over 1 so I can remember I'm multiplying fractions. Now, we need to get, as our answer, mass in grams of aluminum oxide. So we're going to have to use a conversion factor. Now the clue on which of these two, and I'll point to one real quick, which of these two conversion factors we use, the clue to that is found here. If I need to get grams in my answer, then I know that grams will be on top of this conversion factor, because that way I'll have moles on the bottom, and moles will cancel. Now what was this number right here? That's the molar mass of aluminum, which we calculated right here, 102 grams. And when we do the math, it's 9.45 times 102 equals 963.9 grams of aluminum oxide. Now, is that correct? Let's check our significant figures. We have 3 significant figures here and 3 significant figures there. Our answer should have 3 significant figures, so we round it to 964 grams of aluminum to oxide. You should now be able to work number 16 and 17 on page 382. What's the other type of problem we can work with our mole to mass ratio? We can convert from mass to moles. That's the opposite direction. Before we converted from moles to mass, we can convert from mass to moles. This is sample problem 10.6 on page 319. If you're following along in your textbook, when iron is exposed to air, it corrodes to form a red-brown rust. Rust is iron 3 oxide. That's an ionic compound. How many moles of iron 3 oxide are contained in 92.2 grams of pure iron oxide? First, let's find the molar mass of iron 3 oxide. Remember that 3 is the oxidation number. We have 2 irons and 3 oxygens. And iron weighs 55.8 grams per mole. So we have 2 times 55.8 grams per mole plus 3 times 16.0 grams per mole. So together that weighs 159.6 grams per mole. That's the molar mass of iron. Okay? So next, we're going to use 92 grams of pure iron oxide. That's 92.2 grams of iron 2 oxide. Put it over 1 so remember. And we're going to calculate how many moles of, did I say iron 2? I'm sorry, it's iron 3. And so now we're going to use a conversion factor, and that conversion factor, so we know that our conversion factor is going to have moles on top, and it's going to have grams on the bottom. And where does that come from? Right here, our molar mass of iron goes here. 159.6 grams per 1 mole. And when we do the math, we get 0.578 moles of iron oxide. My grams have canceled, and I'm left with mole units. Now you should be able to do problems 18 and 19 on page 319.